Every single night, without fail, your brain does something no machine on earth can fully replicate. It shuts down your muscles. It seals off your senses from the outside world. And then it generates a fully immersive hallucination so convincing that you forget completely that none of it is real. We call it dreaming. And after more than a century of serious scientific research, nobody fully agrees on why it happens. You will spend roughly 6 years of your life dreaming, 6 years trapped inside a stories your own brain invents, stars in, and then almost entirely forgets by morning. For most of the 20th century, the dominant theory came from Sigmund Freud. He believed dreams were coded messages from the unconscious mind, repressed desires disguised in symbolic form, waiting to be decoded on a therapist's couch. Modern neuroscience has moved almost entirely away from that idea. But what has replaced it is, in some ways, even stranger. Neuroscientist Matthew Walker of the University of California, Berkeley, has spent decades studying sleep. His research points to something Freud never considered: dreaming as a form of overnight therapy. During REM sleep, the stage where most vivid dreaming occurs, the brain replays emotional memories from the day. But it does something specific while replaying them. It processes those memories without the stress chemical noradrenaline present. In other words, your brain relives your most emotional experiences while chemically incapable of feeling the same level of stress it felt the first time. Walker calls this overnight therapy. Dreaming, in his model, is not about hiding meaning. It is about stripping the emotional sting from memory so you can carry the information without carrying the pain. This may explain something almost everyone has experienced: a breakup that feels unbearable on day 1 and merely sad by day 30. A traumatic memory that eventually stops triggering a racing heart. Time does not heal that wound alone. Dreaming does the editing. But that is only one theory among several serious contenders. Neuroscientist Antti Revonsuo of the University of Turku argues something almost opposite. He calls it the threat simulation theory. In his view, dreaming evolved as a rehearsal space, a virtual reality simulator your ancestors used to practice responding to danger before they ever encountered it in real life. This would explain why a striking percentage of dreams involve being chased, falling, or facing some kind of threat. Revonsuo's research found that dream content skews heavily toward negative, threatening scenarios far more often than everyday waking life would predict. If your ancestors dreamed of predators attacking and practiced fleeing or fighting in that dream space, their brains got a kind of cost-free rehearsal, no real danger, full simulation. And when the real threat eventually appeared, their brain had already run the scenario. There is a third theory, and it comes from an unlikely place: computer science. Researcher Eric Hole of Tufts University proposed something called the overfitting brain hypothesis, borrowed directly from how artificial intelligence models are trained. When an AI model trains only on narrow, repetitive data, it becomes what engineers call overfit. It gets extremely good at recognizing exactly what it has seen before, and terrible at handling anything new or unexpected. Hall's theory suggests your brain faces the same risk. Waking life is often repetitive. Same commute, same rooms, same faces. If your brain only processed that narrow, repetitive information, it would become rigid, overfit, brittle. Dreams, in this model, function as injected noise, bizarre, unpredictable, nonsensical scenarios that force your neural networks to generalize rather than memorize. The weirder the dream, the better the exercise. This is why dreams so rarely resemble your actual day. A dream that was simply a replay of yesterday would not train your brain to handle novelty. A dream where your childhood home is underwater and your teacher is somehow also your dog does exactly that. Under this theory, the strangeness of dreams is not a bug. It is the entire function. So which theory is correct? Overnight therapy, threat rehearsal, neural noise injection? The honest scientific answer is that they may not be mutually exclusive. The brain during REM sleep is doing an extraordinary amount of work: memory consolidation, emotional processing, synaptic adjustment. It is entirely possible that dreaming serves several of these functions simultaneously, layered on top of each other, all happening in the same nightly hallucination. What almost every researcher agrees on is this: dreaming is not a meaningless byproduct. It is not your brain simply misfiring while you sleep. Every major theory treats dreaming as functional, necessary, something your brain requires, not something it merely tolerates. Sleep deprivation studies make this clear. Deprive a person of REM sleep specifically, even while allowing other sleep stages, and cognitive function deteriorates rapidly. Emotional regulation collapses. Memory formation suffers. The body, quite literally, cannot function properly without access to the dream state, which raises an uncomfortable question. If dreaming is this essential, this functional, this necessary for the human mind to operate correctly, then every night you fall asleep, your brain is not shutting down. It is going to work, building simulations, editing memories, training itself against a world it has not yet encountered. You spend a third of your life unconscious, but your brain has never once stopped working. It just stopped asking your permission to do it while you were awake.